Alright, y'all, back again. We're going to be talking about matrices and systems of equations. So we're going to relate the systems of equations we've been working with to a new thing called matrices. And matrices are something that might seem really unfamiliar and, like a whole new language right now. And that's because it is. There's so much more that go along with matrices. Goes into, coding, graphic design, like a bunch of computer stuff, a bunch of physics stuff. Matrices are a whole other world. So we're just going to be dipping our toes in it right now. And if the water seems a little cold, a little chilly, a little too chilly for you, probably is, but you'll get used to it, and it's something that we're going to have to learn. So matrices and systems of equations relate very directly. If we are here solving our system of equations, what this would look like in matrix form, or when we put equations into matrices, which is the plural form of matrix, we get something that looks like this. So you can see the numbers correspond. The -2 in front of the x right here, the 4 in front of the x right here. So the columns have corresponding variables, right? So we have the 4 in front of the y and the -5 in front of the y. So corresponding variables again. And then here's our solution column. So this is what's called an augmented matrix. And it's augmented because it has the solution column here. A regular matrix would just be something like this. That would just be a regular matrix. But when we augment a matrix, that means we're attaching a solution to it. And that's where we have that dashed line right there. Augmenting a matrix is useful because it helps us find the solution. Something else that we look at when we look at matrices is the rows and the columns, like I was saying. So the columns correspond to the variables, and the rows correspond to the equations, right? So when we count the rows and the columns of matrices, it's very important because this is how we identify them. This is what we use to see if we can do operations on them and things like that. We're going to count the rows. We see there's 1, 2 rows. And we're going to count the columns. There's 1, 2, 3. So this is going to be our 2 by 3 matrix. So once again, this is a 2 by 3 matrix, and we'll use that for operations in the near future. Something else that we'll be using a lot of is these row operations. So as you can see, we have 3 row operations. We can swap 2 rows, we can multiply a row by a constant, and we can add or multiply a row by another. You'll see why we might use these, but I'm just like showing you the tools that we can use before we get going on this project. So our project is going to be to solve for these variables, and how we would do that, like we saw in the examples, was kind of isolating each variable on its own so that we end up with something like this. So this would be our x equals blank number and y equals blank number, right? Because we would just have one coefficient in front of the y, and that would give us the y value, and then we would have the coefficient in front of the x, and that would give us the x value. So we want to end up at this. So if we can turn this left side into this matrix right here, we know that everything else is just going to be the answer. We know that this number is going to correspond to the answer for x, and this entry here is going to correspond to the answer for y, because that's how it corresponds in a system of equations, right? So to make it more clear, what this would look like as a system would be 1x equals x, and 1y equals y, with a 0x and a 0y here, right? But we don't usually write those. So our goal is to end up here. Our tools are laid out right here, and our materials are right here. So now let's get to work. First step, and we're going to keep track of this in a certain way. It's a sort of notation. We're going to call this R1 and this R2, and we're going to operate on one row at a time, only one row at a time. We're going to leave the other row alone as we do so. So the first thing I want to do to get this down to here is I see that I could eliminate this with this. So what I'm going to do is add 2 times row 1 to row 2. So I'm going to do 2 times row 1 plus row 2, and that is going to be my new row 2. So you see how I'm just operating on one row here? I'm using both of them, but I'm only changing one. And so our new matrix, the top row isn't going to change because we didn't mess with that at all. We got -2, 4, 10, and our bottom row is going to be 0, 3, 21. And so now we can see that we've got this. That's nice. So let's keep moving. Let's keep it rolling. Something we can do here. I see that this row, it would be pretty easy to just divide all of it by 3. It would give us a little bit easier numbers. And not only that, but it would also give us that number, right? So if we divide this whole row by 3, so we'll do R2 divided by 3, and that's going to be our new R2. And so to rewrite that down here, once again, we haven't touched the top equation, but on the bottom we have 0, 1, and 7. From here, let's try and get rid of this number. We can turn that into a 0 by subtracting 4. So to turn this into a 4, we'll multiply this whole row by 4. So what we're going to do is row 1 minus 4 row 2, and that's going to be our new row 1. So our matrix then, bottom row does not change. Our top row, after we subtract 4R2, so -2 minus 4 times 0 is -2. 4 times -4 times 1, or 4 minus, -4 times 1. 4 minus 4 times 1 is 0. I had all my negatives and minuses mixed up there. I apologize. But once again, that's 4, which is in row 1, minus 4 times row 2, which gives us 0. And lastly, 10 minus 4 times 7 is going to be -18. So we just have one more thing to change on the left side here. To do that, and all we have to do is divide the whole row by 2. So we'll get back to the black marker here. We'll do row 1 divided by 2 equals row 1, or more, so it should be goes to row 1. Our matrix then, we're actually going to divide by -2, because then we can just get this down to be a 1. Otherwise, we would have to do another step. So it's going to be row 1 divided by -2 is going to be our new row 1. So our final matrix is going to be 1, 0, 0, 1, just like we wanted. And the answers on the right side are going to be 9 and 7. So what that means, if we put this back into a system of equations, we would have x plus 0y, right? Or 1x plus 0y equals 9. And then we would have 0x plus 1y equals 7. So that's how matrices and systems of equations relate, and this is how we can sort of make systems of equations more systematic. You could solve them easier, more streamlined, and then you could turn it all back into a system of equation and still use the information the same way with the solution there. So things to remember: your row operations. Remember your rows in your columns. We're going to be talking about that with operations, addition and multiplication. And yeah, hopefully this wasn't too hard. We got a little more practice for you, and we'll see you in the later videos.